Okay, let's talk about balancing chemical equations. Balancing chemical equations is really just making it so that we follow the conservation of mass. Remember, this means that mass is neither created or destroyed. Okay, what does that mean? That means the mass of your reactants must equal the mass of products, right? If you started with 10 grams of some substance, maybe 3 grams of, just for example, oxygen gas, and 7 grams of, I don't know, magnesium solid. At the end of the day, after once the reaction goes through, you should still have 3 grams of oxygen gas and 7 grams of magnesium oxide, right? Because the oxygen still has to be there. Gas, not gas, mass cannot just disappear. Right, so that's a conservation of mass. Mass is neither created or destroyed. And when we balance chemical equations, we're really just making it so that we follow the conservation of mass. How do we do that? Well, let's look at this example over here. We have C3H8 plus O2 goes to make CO2 and H2O. Now, the non-balanced chemical equation, so just the skeleton equation, my bad, would just be C3H8 plus O2 goes to make CO2 plus H2O, okay? This is assuming that we haven't balanced it, okay? And it'll become apparent to you why it's called balanced. So this is just the bare bones equation. Call it the skeleton equation. This is the skeleton equation. And look, right? First of all, you see some weird things, right? If you have C3H8, well, there's three carbon atoms in this molecule. Where have they gone by the time they go to the reactants? There's only one carbon atom here, okay? And look at the oxygen. We have 2 oxygens here. But by the time the reaction is over, the product side, there's the products. There's the reactants. We somehow have 1, 2, 3 oxygen. So where did that extra oxygen come from? Where did the 2 extra carbons come? And how come we lost 2 carbons when this reaction happened? Okay? Or, what about the hydrogens? We have 8 hydrogens on this side, 8 hydrogens on this molecule, and then only 2 hydrogens in water. Okay? Because this doesn't follow the conservation of mass. So in order for it to follow it, we need to balance it, right? And a good way to visualize it is this diagram over here, okay? You have one C3H8 molecule. You have an O2 molecule, so oxygen, CO2, and H2O. But you don't just have a O2 molecule, you have 5, okay? So what is actually happening when you put oxygen and I believe it's propane together is that for every propane that reacts, you have 5 oxygen molecules going along with it, right? Does that sort of make sense? And for every molecule of propane that you react, you will produce 3 molecules of CO2, right? Because each propane molecule has 3 carbons. You can draw the carbons over here. Has 3 carbons, and each of these carbons, if we drew propane just as these C represents carbons, you imagine breaking up these C's to form 3 carbon dioxides. Okay, this is carbon dioxide. Okay, do you sort of see? Okay, so each of these carbons on the propane molecule will go to make an individual carbon dioxide. Okay, and that's why we have 3 carbon dioxide. For every propane molecule, we have 3 carbon dioxide molecules. Okay, and the same thing with the oxygen, right? Mass in equals mass out. So if we have 10 oxygens here, we need to have 10 oxygens over here as well, right? Because, going back to the propane example, we have 1, 2, 3, right? If we only have 1 oxygen molecule, how are we going to make 3 carbon dioxides? We can't, right? We can make 1 carbon dioxide, this carbon dioxide, but what about this carbon? Okay, where's the other oxygens going to go? In order for that to happen, we need 5 oxygens, okay? two oxygen at 5 O2 molecules for a total of 10 oxygen atoms, because we need 10 oxygen atom. Well, we need 6 oxygen atoms to make the carbon dioxide. 3 times 2, 6, and we need 4 oxygen atoms to make the water that we're going to produce, for a total of 6 plus 4 equals 10. Okay? So what really a balanced chemical equation is saying is that for every propane molecule, you need 5 oxygen molecules. This, by the way, is called propane, if I didn't make that clear. You will produce 3 carbon dioxide molecules and 4 water molecules, okay? If you only have, okay, so that's all it's saying. And that's because you have to follow the conservation mass. If you have 8 hydrogen atoms here, you need to have 8 hydrogen atoms when you come out. If you have 10 oxygen atoms here, you have to have 10 oxygen atoms when you come out, okay? 3 carbon atoms, you have to have 3 carbon atoms when you come out. It's all just a conservation mass. So with that, we could do some examples, right? I'll show you how to balance chemical equations. It's really just simple arithmetic, right? You want to get it so that the numbers are the same on both sides. So the first example, just looking at it, it's just 1, 1, 1, 1, right? If you have 1 magnesium on the products, 1 magnesium on the reactants, okay? 1 potassium on the left side, 1 potassium on the right side, 1 bromide on the left side, 1 bromide on the right side. Okay? Let's do this one. We have calcium, chloride, hydrogen, and oxygen. Okay? Really, it doesn't matter where you start. I tend to start the one that's not balanced. So, for example, you have 2 chlorides here and only 1 chloride here. So, I see that I want to put 2 chlorides and there's 2 hydrogens. That's good. Let's see. Okay, and from here I know, so hydrogens, you have 2 on both sides. Chlorides, you have 2 on both sides as well, because 2 times H, 2 times 1, and 2 times 1. So 2 times 1 hydrogen is 2 hydrogens, 2 times 1 chloride is 2 chlorides. Okay, let's see. Calcium, I can keep it the same, right? Because calcium, you have 1 on both sides. And let's see, carbon, we have 1 on this side, so I might as well make it 1 on this side, and 1 on H2O, and that all balances out. So really, it's just, you just have to practice a lot to get good at it, and we'll go through more examples, okay? Looking at this, do I see anything that is unbalanced? No, not really. So let's see how many carbons we have. We know we have 1 carbon here on the left side, 1 carbon on the right side, so we have 1 carbon. What about oxygen? We have 6 oxygens on both sides. Awesome. Sodium, we have 1 sodium on both sides. And hydrogen, we have 1, 2 on this side and 1, 2 on this side. So it looks like all our, and sodium, did I talk about? Oh yes, I did. Okay, so we look at all our elements and they're all there. So we're going to put 1, 1, 1, 1, 1. Okay. Let's go to the next one, H2O2. We have, so as far as hydrogen goes, we have 2 on both sides. Okay, but what about oxygen? Oxygen, we have 3 on the left side and only 2 on the right side. Okay, so what do we do? Well, the easiest way is just find a common denominator. Not common denominator, least common multiple, right? So oxygen, you have 2 here. Well, what's the common multiple of 3 and 2? That's 6. So how do we make this, the oxygen on the left side of the equation, have 6 oxygen atoms? Multiply by 3. Oh, no, my bad. No. 3. Okay, let's see. Yep, okay, yeah. So how you would balance this is would go like this, right? You would have 4 oxygens on this side, on both sides, and you would also have 4 hydrogens on either side as well. Okay, so yeah, when balancing, it's really just finding lowest common multiple, and just, if you're wrong the first time, you can just erase and try again. Let's say calcium fluoride. I immediately see that the fluorides are not balanced, so I put a 2 over here. So 2 fluorides, but now I have 2 sodiums, so I have to put 2 sodiums here. Let's say the calciums are balanced, so I'll put 1s over here, and lucky enough, the 2 bromides are also balanced. Okay, awesome. Let's do Sodium. Let's see. Well, I'll put two over here because I want to have 2 sodiums, so the sodiums on both sides are balanced. Then let's see. We have 2 NO2, 2 nitrites. So I want to put 2 nitrites over here to balance it out. And that's good. Okay. So really, balanced chemical equations is just a lot of practice, and we'll be doing that a little bit more down the road. This is extremely important part of chemistry. I cannot stress this enough. Important. Balancing chemical equations, extremely important, and you will see it everywhere you go. And how to get good at it is simply just, getting a feel for it. Just knowing that, okay, I need to add a 2 over here, a 1 over here, a 2 over here to get these balanced. Just a lot of practice.